very excited to tell you about some of the research that I'm doing right now. It's in the field of astronomy, and as I described to you the phenomenon that we're trying to understand, it's a big puzzle. It's a major mystery right now. Now, when I try and explain to people, you know, what do we mean by fast radio bursts? Here's a sort of arty kind of cartoon of the sort of thing I want you to have in your mind, something all over the sky that's flashing in unexpected places very briefly and then disappears. Radio is just another part of the electromagnetic spectrum. It is a much lower frequency, longer wavelength kind of light, but it's light all the same. And nature produces all sorts of different light. When you look up at the sky, you're seeing the visible portion because that's what your eyes can see. But if you had antennas for eyes, the sky would look vastly different. And you might notice things flashing off and on all the time. And that's called the phenomenon of fast radio bursts. So what does this phenomenon consist of? Brief bursts of radio waves, as I said. And now I'm going to quantify brief. They last only a few thousandths of a second. That's a few milliseconds. There's a range. There's all sorts of things you can measure here, and we've measured, and some of them are even less than a thousandth of a second, sometimes tens of millionths of a second. Something very brief. The first one of these events was detected or reported in 2007 by a group using the Parkes radio telescope. So about 50 of them have been detected since 2007, but we know that the phenomenon is actually much more common. We can estimate that things are happening about 1,000 times per sky per day. The bottom line is we don't know where they're coming from. So something ubiquitous in the universe of totally unknown origin. We don't know what they are. Now, what do they look like? We take the digitized signal from the radio telescope and we put it into computers, and we're now showing you a digital version of what we actually see. And so just look at this inset for a moment. Time is going on this axis, and basically there's nothing but noise coming from the radio telescope initially, and then there's the burst. The burst happens, it gets really bright, and then it goes away and it does not come back. So that's the burst. But that's actually a simplified version of what we see. In fact, the radio telescope, the antenna that's on the radio telescope in the focus there is sensitive to a wide range of radio frequencies. And if you look at all the different radio frequencies that it's sensitive to, that's what this bigger plot is. Time is still on this axis, so time is moving along here. And on this axis is radio frequency. But what happens is the signal does not arrive at all the radio frequencies at the same time. And this is a phenomenon called dispersion. The signal arrives earliest at the highest radio frequencies, and it sweeps through the band as you look, you're sensitive to all these frequencies, but it comes in at the highest radio frequencies first, and it's delayed at the lower radio frequencies. And this signal, by virtue of the fact that it sweeps in and arrives at different times at different radio frequencies, that's the crucial piece of information, is what's telling us that these events are coming from far, far outside the Milky Way galaxy. They're coming, in fact, what we infer from just that sweep right there is that they're probably coming from the furthest reaches of the universe, from what we call cosmological distances. Now, when I say that the events are coming from far, far outside our galaxy and from cosmological distances, the largest scales in the universe, that's where they're coming from. And we could tell all of that from that dispersive sweep. So as long as that light's traveling in a vacuum, then the speed of light is constant and the same for all colors of light. And that's all across the full electromagnetic spectrum. Optical, radio, gamma ray, everything, C. But in a medium that is not in a vacuum, the speeds are different. And space, interstellar space is not a vacuum. It is filled with all sorts of there's dust, there's neutral atoms, there's ionized atoms in particular, there's free electrons. And it's those free electrons that disperse radio waves. So the prism, in the analogy between the dispersion of white light into the colors of the rainbow, the free electrons in our galaxy act as a prism for radio waves. If you see some galactic source from a certain direction, you can measure the sweep of its radio waves, and then, so we know something happened at a certain distance, there's a certain sweep in how radio waves arrive. That tells us the distance, roughly speaking, to the source. And in particular, from our knowledge of the distribution of electrons in the galaxy from galactic sources, we know what the maximum is in any direction. And so this is how we determine distances. The fast radio burst source goes off. It emits all radio frequencies at the same time, but as they travel through free electrons in interstellar and intergalactic space, they get delayed because of dispersion and spread out. The sweep we saw was over 10 times the maximum sweep our galaxy can possibly produce. The models of the free electrons that we've built from years and years of observations of galactic sources tell us this thing has to be way outside our galaxy. And by way outside our galaxy, I mean it has to be at a cosmological distance. And if it's coming from a cosmological distance, if it's that far away, then intrinsically it must have been very, very bright. So, you know, this phenomenon is kind of frightening. This is something ubiquitous, 1,000 times per sky per day. We don't know what's causing it, but it's for cosmological distance visible here on Earth, something extremely bright. And so what are these things? Exploding stars, something exploding, colliding stars, colliding neutron star black hole. There's a paper on comets and asteroids impacting neutron stars, black holes evaporating, primordial cosmic string oscillations, all sorts of ideas out there. But the bottom line is we don't know the answer. But let me tell you about a major clue that we got from a fast radio burst that was detected at this observatory, which is the Arecibo Observatory in Puerto Rico. This is now a much larger telescope than Parkes. This is 300 meters across. So that's 5 football fields. Here's the fast radio burst that we detected at Arecibo. And you can see the telltale, the sweep there, the dispersive sweep. And this was, for a long time, the only burst detected by Arecibo. And it was actually the first one detected at a telescope that was not the Parkes telescope. So the Parkes people were really relieved when we found it because they were terrified there was something else going on at their telescope. Then we decided that we should be, even though Parkes had been looking at all the fast radio bursts they detected and never seen anything else from those positions, like it was a one-off event, we sat on this one and we watched this position for many, many months, and also we didn't see anything until one day. We went back to that spot and we saw 10 more bursts from the same source. And this was a big shock. We were not at all expecting this. Now, in this plot, we've taken out the dispersion, just corrected for it, delayed the lower frequencies so that they line up vertically. And you can see all of the different bursts from the source. Some are incredibly bright, some are incredibly weak. Some are very bright across all radio frequencies. Some are only in the bottom part of the frequency band. We were all shocked. It repeats. Once you have one that repeats, well, that's big. Because, you know, you would really like to know, or are these things coming from a galaxy? And with the Parkes events, you can't know that. And the problem is there's thousands of galaxies there that it could have come from. You can't know. And even Arecibo actually can pinpoint things a little bit better, but still there's hundreds of galaxies in the error region of the Arecibo telescope. It doesn't help you. What you really want is a different kind of radio telescope called an interferometer that can pinpoint things really well, the very large array. But the problem is that anything that can pinpoint can't detect them because they're looking at too small a fraction of the sky and the things are bursting elsewhere. But once you have one that repeats, you can go with an interferometer like the Very Large Array in New Mexico. We said, hey, there's something that repeats. If you just wait and you look over there, because it pinpoints so well, we're going to know where it's coming from, and then we can look and see if there's a galaxy. And we looked and looked for months, and nothing happened. The source did not cooperate. We had seen it repeat at Arecibo, so we knew it did. And eventually, they were getting pretty sick of us at that telescope, but eventually it burst, and there was a big boom, and this was incredibly exciting. We actually got 9 bursts with the VLA, so we got a precise sky position, and we went to the Gemini telescope and looked, and this is what we saw optically. It turns out there was it was incredibly faint. We really needed a large 8-meter telescope to detect that the fast radio burst was coming from a dwarf galaxy. So it turns out there's many different types of galaxies, and they're not all giant, beautiful spiral galaxies like the Milky Way. There's all these smaller galaxies, and this huge radio burst that was coming. It was a total shock. We had no idea from a dwarf galaxy. But the good thing was that even though it was a tiny galaxy, we could still measure an independent distance. In fact, it exactly agreed with what we predicted from the dispersion. So we knew it's definitely at a cosmological distance. So FRBs, where do we stand? So at least one FRB repeats. Obviously, neutron stars can't collide over and over and over again. Okay? So immediately that source ruled out a whole class of models. Anything cataclysmic, anything where the source of the event destroys itself in the process, well, that's out, at least for that one source. And we have confirmed for that source that they're indeed cosmological, as we had inferred indirectly from the dispersion. But the open questions, do they all repeat? Do some just repeat more often than others? We don't know. What is the bursting source? What keeps repeating? We don't know. And why is it in a tiny little galaxy? You know, you might have thought something that bright would be in a larger galaxy. So, you know, basically, there's all these puzzles, lots of unanswered questions still. We need to find more of these. And that's where this new telescope, the CHIME telescope that we've built near Penticton, British Columbia, comes into the picture. It consists of 4 cylinders, cylindrical reflectors. And basically, on the axis of each of these cylinders are hanging 256 radio antennas that are sensitive in the frequency range 400 to 800 megahertz. The total input data rate after digitizing these signals going into the supercomputer is 13 terabits per second, which is comparable to the entire cellular network in the world. I do think a lot of the press that we get has to do with us using terms like radio signals, which might suggest to some people that this is not a natural phenomenon. That was never our intention to suggest anything like that. We are very confident this is a natural phenomenon. It has nothing to do with any intelligent, life forms. But we get a lot of press out of it. So, in any case, I don't think they're aliens. I just want to be crystal clear about that.
Yeah. So we've known for almost a century that the universe is expanding, and that as you go back in time to earlier times, it was hotter and denser. And in particular, the universe is filled with a background of radiation that emerged from this early hot state. And this radiation started traveling through the universe when it became transparent, about 400,000 years after the Big Bang. Back then, it had a very high temperature, roughly half of the temperature at the surface of the sun, about a few thousand degrees Kelvin. So it was very hot 400,000 years after the Big Bang. But today, this radiation has a temperature of only 2.73 degrees above absolute zero. But in between those two times, between the present time and 400,000 years after the Big Bang, very early on, there was a time when the temperature was comfortable, similar to a sunny day. And I realized that the first stars in the universe formed roughly tens of millions of years after the Big Bang. And that's very close to the time when the temperature of the cosmic microwave background was 300 degrees above absolute zero, comparable to the temperature on the surface of the Earth on a sunny day. So I was thinking, well, that's an interesting coincidence that the first stars formed just around the time when the entire universe was warm enough to keep water in a liquid form. And if you had a planet, the planet doesn't need to be at the right distance from its host star in order to be warm. It could be anywhere, and the entire universe would act as an incubator. And the significance, as far as I'm concerned, of this is to try and encourage people to think about the emergence of life, not just near stars the way we know it in our galaxy, but earlier in the universe. We are not at the center of things, and the universe might be full of life, and life may have started much earlier than it did on Earth. We may be relatively latecomers to this game, and the universe may be full of life, but it's hard to see it, to detect the evidence for it. Right now, astronomers are thinking about ways to detect biomarkers. Last summer, I checked the numbers, whether a nuclear war on an exoplanet might be detectable, and I realized that the flash of light that would be produced would not be detectable even when dealing with the nearest star to us. And so such an event, a nuclear war, that we regard as an unusual event that releases a lot of energy, is not even visible with the biggest telescopes we have. Even if life did not start 15 million years after the Big Bang, my intuition is that it definitely, the chemistry that could lead to large molecules, primitive life, the chemistry in liquid water could have definitely started hundreds of millions of years after the Big Bang, or for sure a billion years after the Big Bang. It didn't need to wait all the way till the present time for life to have emerged, because heavy elements were produced. We have direct evidence that heavy elements were produced hundreds of millions of years after the Big Bang. So when I say life, I mean, the idea is that it's life as we know it, but if you expand that to a larger variety of life forms, it might be even more pervasive than I can imagine. There is this famous question that Enrico Fermi, a famous physicist, asked, why aren't they here? If they exist, if there are intelligent civilizations, why haven't we seen them already? And there are many possible answers to that. The one that I like the most makes the analogy with ants on a pavement. When you walk down the street, you don't pay attention to the small ants that are moving around the pavement, and we might be so technologically inferior that they don't even care about us. We don't have anything special that attracts their attention at the moment. So it's quite possible that we haven't found evidence for them because they're much more advanced than we are. But the only way to find out is to search for possible signals that cannot be produced naturally by natural sources. And there is a search for that. It's called SETI, the Search for Extraterrestrial Intelligence, and it's sort of like searching for a needle in a haystack, because we don't know what to expect. One guiding principle could be, let's search for radio signals from exoplanets, planets that are neighboring other stars in the habitable zone of other stars. And that, of course, would make some sense, because our civilization has leakage of radio waves steadily. We are just sending out radio waves to space without much concern. We started doing so already 60 years ago.
Fast radio bursts, which are very bright bursts of flashes of radio waves, are coming from random directions in the sky, and the current estimate is that there are thousands of them, or even more than that, fainter ones that we haven't detected yet, up to 1 per second, coming from the entire universe. We see much fainter flashes of radio waves from pulsars. These are neutron stars that are spinning and repeating periodically, like lighthouses. But these are usually fainter by 1 billion times fainter than the fast radio bursts. We don't really know conclusively where they come from. There is one that seems to repeat, and that allowed people to find it, locate it more precisely And that one seems to originate in a dwarf galaxy, a small galaxy at a cosmological distance. But we don't know where most of them come from. And in the spirit of being open-minded, I wrote a paper with my postdoc Manasvi Lingam on the possibility that we might be seeing a flash of light that is associated with light sail propulsion, with the kind of signal you expect when a beam of light is crossing your line of sight. And so we were thinking of propelling a spacecraft at a fifth of the speed of light, such that it would reach Proxima Centauri within 20 years. The star is about 4 light years away, so it will take 20 years to reach it at a fifth of the speed of light. Even with nuclear fuel, you don't have enough energy per unit mass to produce a rocket that will reach that speed. So there is a limiting speed that you can reach with a rocket, which is dictated by the energy per unit mass of its fuel. You need a completely different technology that leaves the fuel behind. And one way to do it is by using a very powerful laser beam, a beam of light, shining on a sail and pushing it through the reflection of the light. So it's just like a sailboat being pushed by wind. Here, the push is coming from the reflection of light rather than the reflection of air molecules of the sail. And since light moves at the speed of light, you can in principle reach a fifth of the speed of light. For that, you need a laser as powerful as 100 gigawatt, which we don't have at the moment. And you also need a very lightweight payload and sail of the order of a few grams. And if you go through the numbers, you find that with a few grams a sail and 100 gigawatt shining on it for about a few minutes, it can reach a fifth of the speed of light over a distance that is about 5 times the distance to the moon. You know, if there is another civilization using laser propulsion or radio wave propulsion, then it focuses it to a very narrow beam, pushing on the sail, but there is some leakage of the light around the sail. And when that light crosses our view, it appears as a flash of light. The reason it moves across the sky is because the source is moving, we are moving, and so we see it only for an instant of time. And so we found out that potentially, if there is a civilization that is harnessing all the radiation from its host star in the habitable zone of a sun-like star, it could potentially produce, and it's using all of this energy that is intercepting the surface of the planet. It's using it for propulsion by beaming, producing a radio beam that is pushing on a sail. Then even at cosmological distances, that could be detectable as a fast radio burst. It could be that they come from a mix of sources and that a small fraction of them are artificially produced. And, you know, we should just keep collecting data. And I'm just waiting for the one fast radio burst that will take place in our own galaxy, because that would be 1 billion times brighter than those that come from cosmological distances. These are radio waves, so as I said, it's something that is detectable with a cell phone, and that means that such intensity is going through our bodies at all times. Nothing much stronger than that, you know, and we could learn a lot about its origin. If such a technology was developed by another civilization, we won't notice those probes because they're so small and they move so fast. Last year, there was the first object that was discovered that passed through the solar system. And surprisingly, this object appeared very elongated, needle-like, with its width being just a tenth of its length, which resembles the kind of design we had in mind for the cruise phase of Starshot, when we want to minimize the cross-section of the spacecraft such that it will not be damaged by impact of dust grains or interstellar atoms on its surface. And so as soon as I heard about this object, I contacted Yuri Milner and said, this is very peculiar. This object is very elongated, and we should probably think about checking whether it transmits any signals. And we had a discussion about that and decided to look at it with Breakthrough Listen, the same radio telescopes that are looking at other stars. And the observations were able to put a limit of less than a tenth of the transmission of a cell phone. So in other words, there is no radio transmission at the frequencies we looked at.
But let me add a few more strange facts about it. All the objects that we have seen that were born in the solar system, such as asteroids or comets, at most had a brightness variation of order 1 to 3. Okay, so this one was extreme in that sense, 1 to 10. So the first peculiar fact is the object must be extreme. And some people analyzed the tumbling motion of this object and concluded that if it was kicked around a lot, then it's most likely to be pancake-shaped. If it's excited, very excited by all kinds of kicks. It looks like this object has no cometary tail. We don't see any tail around this object. So people thought, oh, it's not a comet. But nevertheless, what happens is that this object seems to deviate from the orbit that you expect based on just the sun's gravity. The only other way that people considered in the past for such a deviation is cometary outgassing, where there is evaporation from the surface of the comet, but we don't see anything like it. I should say that the deviation is small. It's at the level of 0.1%, but it's very significant because you need about 10% of the object to evaporate. Mm-hmm. It needs to lose about 1/10 of its mass in order to give it enough push that would account for the deviation from the orbit that we see. And so we don't see a cometary tail. Moreover, the Spitzer Space Telescope looked at this object and didn't detect any carbon monoxide, carbon dioxide, all kinds of gases that usually are associated with outgassing from a comet. And moreover, the Spitzer Space Telescope tried to look for thermal emission, heat from it, coming off it, and didn't detect any heat. And that implies that the object is relatively small. And the limit is of order 100 meters to 200 meters. So it needs to be smaller than that size. But we know how much sunlight was reflected off it. And so given the size limit, we can say that it's very shiny. It was smaller than 100 meters, but more than 10 to 20% reflective. It reflected more than 1/10 of the sunlight that was falling on its surface. And that's at the upper end of all the objects that we have seen in the solar system. So it's about 10 times more shiny than a typical comet or a typical asteroid. So it is a shiny, small object that is probably pancake-shaped, mm-hmm. with at least 10 times larger size than its width, or more than that. We don't know. These were the kind of strange facts. And then there is one last strange fact, and that's that the origin of the object is from a very special frame of reference. And, it's just strange. And one way to think of it is sort of like a buoy sitting on the surface of the ocean and at rest. And then the solar system, just like a ship, runs into it and kicks it. Oumuamua was strange in that respect as well. It was in a special frame of reference and the solar system just ran into it. And then the question still remains, what gave Oumuamua an extra push? In addition to the force of gravity from the sun, what if it's not cometary outgassing, which is the usual force that is pushing on comets? If there is no cometary tail, there is nothing else to push. What else can push it? And the only thing that I could think of is sunlight itself. And in order for sunlight to push it when it reflects off it, the only way to do it is to make the object very thin. And we calculated in our paper with Shmuel Bialy, we calculated how thin it should be, and we found that it should be less than 1 millimeter thick. The only thing that one can imagine in this context is a light sail, a sail that is pushed by light, which is a technology that we are currently developing here on Earth. we now know that about a quarter of all the stars in the Milky Way galaxy have a planet of the size of the Earth that is in the habitable zone. In other words, it has a surface temperature that allows liquid water to exist and the chemistry of life as we know it. So it means that you roll the dice so many times, a quarter of all the stars, we are talking about tens of billions of stars, you roll the dice tens of billions of times. What's the chance that we will be the only ones? I think it's very small. I think out of modesty, just admitting that we are not special, if you start from that point of view, that then you must accept the possibility that there is another or many other civilizations out there, and there might be traffic, there might be space debris that is sent out by these civilizations. So to me, it's not a speculative idea. I think it's a reasonable idea that should be part of the mainstream to search for signals or artifacts from such civilizations that are not ours. And of course, most of these civilizations may not be around anymore, might be dead, because
Sure.
If you look at our civilization, the moment we started developing advanced technologies, we also developed the means for our own destruction. We have nuclear weapons,
Right.
we have the ability to change the climate on Earth, and so you can imagine that technological civilizations are short-lived, that they have a finite lifetime, which is relatively short, hundreds of years, thousands of years, and that's it. And that's why at any given time, there might not be many alive at the same time. But on the other hand, even if that's the case, whatever relics they sent out to space or whatever artifacts they produced should be out there. And so, we can search for dead civilizations. We can search for, I call it space archaeology.
If you ask about the risks for life, the biggest risks for life from astrophysical sources on Earth is coming from asteroid impacts. Every now and then an asteroid impacts the Earth, and there are so-called the killer asteroids that are big enough that could, just like they killed the dinosaurs, can kill us. Then there is a risk from the sun itself. The sun has flares, and there was a giant flare back about a century and a half ago that is called the Carrington event. If it would have happened today, it would have caused damage at the level of a few $1 trillion. And simply because of the infrastructure that we have right now, if we do not protect it, it could have damaged a lot of our power grid and satellites and so forth. There is a lot of real estate that is vulnerable to a powerful solar flare of the type that just took place a century and a half ago. So if there is something more powerful than that, which could happen every 1,000 years or every 10,000 years, that could have some repercussions for life on Earth. And of course, that's the reason why living next to a dwarf star is more risky, because those stars flare much more often than the sun.
Was an ancient city. I believe that was abandoned for some reason, and after thousands of years, the Inca went to Cusco, rebuilt their city, but now because of their construction and then Spanish construction and modern construction, it's difficult to see the oldest parts. But as you train your eyes, you automatically see the different periods of building. The oldest is always the biggest stone and always the finest stone, and that's counter to what we're taught about society. What archaeologists say is that as soon as the Inca started to build the city of Cusco, they did this kind of work. But what you'll see, again, up above, you'll see that is Inca style, but it's based on a foundation of megalithic blocks, and the megalithic work is far more sophisticated than what the Inca did. So this is insinuating that the megalithic wall is older. There is no mortar, there's no clay, there's no cement, there's no glue. This is stone on top of stone. And the precision of the construction is so tight-fitting, you cannot fit a human hair in between the blocks. And it's more than a meter thick. It's not hollow. It's continuous. And that would not be impossible today, but would be an incredible technical challenge. As well, we find these strange knobs exposed, and there has been no proper reasoning as to why they exist. And this is my favorite, because this is a drill hole in a stone. Both ends of the stone are broken, so we have no idea how far that hole went. And if you look at the scarring marks horizontally, you can see, and engineers have backed this up, modern engineers, that it must have been some kind of boring tool. The teeth would have had to have been something like diamond in order to cut through, because this is harder than granite. What we see at most of the major Inca, so-called Inca sites, is you'll see three levels of construction. You see very precise cutting and shaping. Next to it, you have stones interlocking into it without mortar. And then in the back, you have mortar work. And the work in the back we know is Inca, but whoever did this other, we honestly, we theorize. And here is a site called Pisac, and you can see the wall in the front is of much higher quality than the work in the back. This is one of the most profound sites in Peru, and this is called Sacsayhuaman. Some Russian geologists took samples from this site and analyzed it, and they honestly believe that what it is concrete. But not concrete that you pour, some kind of concrete you can shape. And that the wall itself, or the stones on the surface, have been heat treated to at least 1,000 degrees Celsius. And at the site of Ollantaytambo, which is actually one of the largest complexes in Peru, or actually the world, we distinctly see very different styles of construction. What you see are the magnificent Inca terraces here, which the Inca were responsible for. They were masters of agriculture and engineering on a Bronze Age level. But as we go higher up, then we start to encounter other ways of construction which are far more difficult. And what is likely is that this again was an example of what happened when there was a cataclysm in the distant past, destroying the beautiful megalithic ancient things, and then when the Inca arrived, they rebuilt around it. And Machu Picchu, of course, is the most famous ancient site in South America, said to have been built by the Inca over the course of 30 years, about 600 years ago. But once you start to look at the stonework in Cusco and other places and visit Machu Picchu, you start to see the same situation. You see, obviously, the Inca did an incredible amount of work in this location, such as these amazing terraces. But you see, it's stone stacked upon stone. It's all local stone, which has been used. But this is a photograph from 1911 when it was discovered by Hiram Bingham. And already you can see the difference. Again, you see quite rough work, but then this megalithic area, which is in the spiritual core of the city. And then Tiwanaku and Pumapunku, which is the strangest place on the planet, I believe. A lot of people, many people believe ancient aliens were responsible for its construction, but it's the precision of the stonework is profound.
Are we dealing with an extraterrestrial civilization? I don't have anything against extraterrestrials. I think the universe is full of life. I actually think that's what the universe is for. I think it's a home for life, a home for experience. But I haven't found it necessary in my work to go down the ancient astronaut route. particularly. I've preferred to look at the mystery of a possible lost human civilization. Really wanting to get to grips with the whole issue of a lost civilization, the thing that really struck me was at the end of the Ice Age was a mysterious and cataclysmic episode when extraordinary earth changes did take place, when sea level rose by 400 feet, when more than 10 million square miles of the best land on earth was flooded by those rising seas.
One of the conclusions that I came to with my research on supernatural is that certain categories of beings that are referred to in traditions all around the world, shamans call them spirits. In medieval Europe, they were called fairies and elves. And in modern society, I would suggest they're called aliens. That all of these are the result of experiences in altered states of consciousness. And that if we are in the alert problem-solving mode of consciousness, we are not going to have those experiences. But in an altered state of consciousness, there's a remarkable unanimity and uniformity and similarity amongst these three supposedly different categories of beings: spirits, fairies, and so-called aliens today. I really went into this in some depth in my research, and I found that there are really astonishing similarities amongst these three categories of beings. Very commonly, shamans, just as we saw from the painted caves, will encounter a spirit being in a therianthropic form, part animal and part human. I was astonished to discover that fairies in medieval Europe were also very frequently encountered in that form. And I have a woodcut from Holland in the 15th century on my desk, which shows a group of fairies dancing in a ring. And if you look closely at them, you see that they are therianthropes, that they have horns and hooves, that they're part animal and part human. And again, in the modern phenomenon of alien abductions, and we have massive documentation on this as a result of John Mack's work, for example. Very frequently, the abductee will first see a being who is an animal, or part animal and part human in form, later perhaps transforms into the more familiar grey type of entity. So there's that common motif running through all three of these experiences. What were fairies best known for and feared for in medieval Europe? It was abducting human beings. What are aliens today best known and feared for? Abductions. What happens with shamans? Very frequently they experience an abduction into the spirit world. It's their first encounter. What about the issue of interbreeding with supernatural beings? I know the cases of shamans who have a sexual partner in the spirit world, a wife, even children in the spirit world. Fairies were constantly amorous towards human beings and would have sexual encounters, and babies would be created. And again, this is a standard motif of modern alien abductions. So one can go through these astonishing similarities in enormous depth, and the conclusion that I came to is that all of these are essentially the same experience, just being viewed through slightly different cultural spectacles. And, to cut a long story short, I would say that the beings that shamans call spirits, the beings that medieval Europeans called fairies and elves, and the beings that modern Americans call aliens are all the same beings. That everybody who has encountered these beings in whatever period of history or whatever culture it takes place has done so through the medium of an altered state of consciousness. And that altered state of consciousness may be very frequently spontaneous, and I believe that is most likely the case with the modern UFO abduction, alien abduction phenomenon, that these are individuals who spontaneously fall into an altered state of consciousness. Or it may be induced by a variety of techniques.
Our universe, is it the only one? Well, currently that's our next big thing we are trying to figure out. There are some claims that are backed up a bit, like that our universe touched another or collided with another. So then, what would those universes look like and be like? So obviously in other universes, the laws of physics likely will not be there. Gravity, light, atoms, or material as we know it will likely be completely different. But you may even have other laws that would apply only to that universe. Heck, light or anything visible may not even be a concept in that universe. Everything would be just dark to us, dark to our senses, meaning our senses would be likely completely useless in that universe.
So you could not even imagine what would it be like.
You may not even be limited to 3 dimensions. The 4th dimension might be in that universe, and that universe may not even be as elegant as ours is, with planets, stars, galaxies. Maybe another universe, it would be chaotic, and anything that would have a mind could not be formed in such a universe. Time may even be passing differently, if there is even time in such a universe. Basically, everything as we know it could be different.